hoping that you guys can build these your own. They're not expensive to build, and you guys can get have your own fun with these because instead of them being a permanent magnet, these have permanent electric fields. So how I got this strange sort of shape here is I buy candy molds, which I'll show you in a little bit, and those silicone molds that you bake in, I decided to just put these two plastics here under an electric field, and then this is what came out. Okay, let's see here. All right, so here's another view of it. The clear parts, again, are the polypropylene. Polypropylene's super cheap. You can get 25 pounds of it for something like 20 bucks. Um, but the Teflon's a little more expensive, but still not bad. Here's another view. So you can hear it's translucent. What's interesting though is Teflon doesn't want to mix with anything. Teflon is your best friend and your worst enemy. But you'll see that it disperses unequally. And actually, this is a good thing, even though at first I was trying to get rid of it. And the reason why it's good is because it creates all these uneven gradients where it's stronger negative, less negative, and because it has all these different gradients, I can actually extract energy from it without having to go through much work. In fact, I can extract energy from it just by putting it in proximity of something. So here's another picture of it. Now here's coming fresh out of the box. It's probably 2 weeks old. I put it in tinfoil for 2 weeks. This is my version 2. I was going to teach you version 3, but I don't have it. Look at the powerful field here. Look at that. This is an aluminum rotor, and the power of this little piece of plastic is so strong that it just yanks these aluminum rotors. And so um, this is basically it. Just polypropylene and Teflon. I'll give you a few more steps later. It's not perfect. It's not a clean mix. It's a little burnt on top, but it works, and it works well. I'm working on my 2.5 generation 2.5 lab, and as you can see here at the bottom here, I have mica, and the reason why I'm using mica is because this thrift store barbecue grill um, tends to short out and cause more sparks. But because I have the mic at the bottom, it causes more sparks and energy to appear between the plates. And that's what I'm wanting to build stronger electrets. There's another example of it. Um, Copper plate, ziggurat mold, copper plate, and then mica. And it's on a cheap barbecue, and I turn the barbecue up about to its maximum, which is about 450 degrees. Um, the thing about mica is it is a conductor of heat, but it's not a conductor of electricity. So what happens is that even though it's 450 on the grill here, it's about 350, 400 on the mica surface, and that gives me I need a minimum of 350 degrees at all times to work with all the plastics I work with. You really need 350, 375 if you can as a maximum. Um, so with this setup, I'm able to achieve not only this is about 100,000 volts, but which is triple of what I've been using on the electric that you just saw. So I'm hoping triple the results, triple the strength of the field. Here's another view of it with the lights on. You can see that all the edges, the whole thing is just turning blue. This is because of the mica. If I didn't have the mica, then it would only be coming out one corner or two. But because there's no place for the electricity to go, all the plasma is forced right here within the vicinity. So the whole thing is just rip roaring with super high voltage fields. This was the picture that I sent Nathan for the thumbnail. So here is sort of a look into how I store and catalog the electrets. They're all stored in aluminum because aluminum shorts the field and allows the field to grow stronger. If I take the aluminum off, then it won't be able to self-charge. And so what I mean is If you've ever taken a piece of metal, a piece of steel, and you've connected it to a magnet, on the other side of the magnet of the steel, sorry, you won't have any magnetism. And the reason is all the magnetism is going into the piece of steel. It's the same thing here. We have electric fields, not magnetic fields, and all those electric fields are going right into the aluminum. And then this allows the fields to come back in on themselves in a stronger way. And then it starts assisting in what is called the polarization. The goal really for an electret is to take all the molecules and have them face one way. And if you can have them all face one way, it'll become a permanent electric field and it'll be very powerful. And so that's really the goal. I can't find a better way yet to store these so they get charged. I know Nathan put out a really good video on why the electrics get charged and the role of aluminum foil in that charge. So you might want to look up that video, or maybe Nathan can post it in the chat. But um, right now, it's the best I can do. I know that Nathan had an idea where I should wrap it up in aluminum mesh. So when I get some aluminum mesh, I'll do that experiment as well. And so this is basically how I catalog them and keep them. And we're looking at these are 2 months old, 2.5 months old are the maximum. And it always fascinates me because when I pull them out, they work. Take my measurements, and I'm surprised. Here's the power supply. This power supply really is, you want to try to find it if you have any interest in electrets, or if you have any interest in a powerful electrostatic field and you want to be able to run it all day and it's always going to work and it's never going to burn out, these power supplies are it. And this is what's called a precipitator power supply. So if you go to AliExpress, look for precipitator power supplies. This is a really good one. It has two channels, has 2.5 kilovolts to 15 kilovolts on one channel, and then another channel has 5 kilovolts to 30 kilovolts, and it only has 10 milliamps. So it's not really as dangerous as you think it would be. If this was a neon sign transformer power supply, it would be way deadlier. But this is not really deadly. I mean, definitely don't test it if it's deadly. I claim no responsibility. If you buy this, you know what you're doing. Buy this only if you know what you're doing. But if you know what you're doing, and you know a little bit about high voltage, you'll find that this power supply, they're cheap for what it does. If you want a comparable power supply that does what this does, I was pricing them, and they're in the thousands and thousands of dollar range. So you just can't beat this deal. Now you can buy those little black cigar looking high voltage generators that they have on Amazon, and they're really cool. And they have a really good feel. But the problem with those is they burn out and they're not consistent. Here I was running this arc, it's about 2.5 inches. This can actually run 6 inches. It's quiet, you can't hear it. I mean, it's just a gentle hum, not even a hum, it's quieter than that. It's like a whisper. But you can see how pure, how powerful it looks. Of course, I can get about 6 inches. This is the kind of electricity that I'm putting in. Now you'll see that I have a step-up transformer. That's the step-up our 110 electricity in our outlet here in America. And it steps up to 212. And the reason why I'm doing this is because if you go on eBay and buy these precipitator high voltage power supplies on for 220, you'll pay half the price for them. And all you need to do is pick up a step up transformer and you're golden. You'll save lots of money. So I paid about 80 bucks for this, and to get a comparable high voltage power supply in the thousands of dollars, 80 bucks is not a bad deal. Not a bad deal at all. Some of my steps are going to be out of order, and of course that's par for the course for my filming, but here I'm setting up now to where I'm going to start adding frequency. And I'm introducing this, which is showing you how I'm going to, I always score or scratch or sand all the copper I use. There's a mica plate. You're going to notice there's a little hydraulic jack here. And the hydraulic jack pushes between 3 and 6 tons. I think it's 6 tons. And what I'm doing here is uh, this also heats up the plate. So this is called a hot press. Now, this aluminum plate up here and this aluminum plate down here, they're separated by a big, thick chunk of wood. That wood is bamboo. And I did some Googling. And bamboo has some unique properties, but what this is it's called a hot press. And in this little digital displays on the lower left-hand corner, you'll adjust those, and that'll give you a temperature on the top plate, and then you'll adjust the other controls, give you the temperature on the bottom plate. These go up as high as 400 degrees. Um, Now, of course, this is not a hot press is not made for electrets. Nothing I use is made for electrets. Um, this is made for if you want to put herbs and you want to squeeze out the resin or the vitamins or whatever out of the herbs, or people put marijuana in here and they'll get the CBD oils because if you dial in the temperature, dial in the pressure, and it'll crush out those resins. And so that's the purpose of this. But for me, I was hoping to get the heat on top and bottom, melt the plastics, keep it in the mold, run a lot of electricity through it, and see how strong I can get my electrodes by adding just a little bit of pressure. And here is just a picture of a top electrode and the materials inside, and then the bottom electrode on top of mica. Mica is that amazing that I showed you earlier. A mica is actually quite expensive. Um, if you buy it for what it's used usually in microwaves. That little vent that protects the filter in your microwave, it needs to be able to take a lot of heat and dissipate it, and so mica is really good for that. But they're very expensive. I found these sheets here on kids crafting, and they usually kids will cut these up into certain shapes and do crafts with them. And I paid a quarter the price, and so I was really happy to find this on eBay. You can't go wrong with mica with its ability to transfer heat but keep electricity out. If you really want to contain plasma and get the highest pressure plasma, mica is your material. Here I'm kind of walking you through. There's the mold, and then I'm going to put the top plate and and then show you here. I'll jack it up with the pressure here, and you can see that now it's sandwiched in. There's a a PVC mold, two copper plates, and then I just fill it in with that polypropylene and Teflon. Sorry about this. This is kind of again the setup. The name of this is called Depress, DABPRESS. If you want to look it up, if you're interested in getting one of these, they're not too expensive. I would recommend getting a larger one than I have. In fact, if you're looking into getting into this at all, I would say get the biggest one you can find because this one's I've already outgrown this one. Here you can see now I'm just showing you the steps of how I build it. Now, of course, this is just a dry test, dry run here. Oh, by the way, you guys might have noticed that I have some color in my face. Oh, I should do this. You actually know what I look like without being on the surface of the sun. This has been a huge important meter. That meter tells you if the air is breathable or not. So um, that meter has been important to me because I tend to melt these plastics and don't have good ventilation. And so that's telling me when I need to chill out or get some ventilation. So here now you see I have the hot press, I have the mold, I have everything. Now I have the electricity running through it, and kind of show you the field that I'm creating in between the plates on the hot press. The end goal for me is to really incorporate as much as I can to make these electric. What I mean is vibration, heat, pressure, electric field, and just keep adding on and on many as I can because I really believe that I can harmonize and polarize the molecules and get a stronger permanent electric field in the plastic discs and other shapes that I'm making electrics out of. You can kind of see now how the air is okay. I got R2D2 here. He's sucking up the fumes, and it's helpful. Most of my electric lab is in the garage. I had to pull this inside my little lab because there's been a heat wave here, and I haven't been feeling well. You can see now that I put the powder in there. You can see the infrared on how I'm heating it up. You can see the different temperatures. And of course, the goal is to have consistent heat on the top and the bottom of the electret. And so I'm just kind of giving you an idea of how I'm always relying on the infrared to see how things are going and to manage temperature. What you basically want is just consistent temperature on your electret. There's another close up inside. Um, Now I added a little bit more pressure, and so you can see that it's a little bit smaller. I'm hoping to get that extra effect. The extra effect of polarization. The heat transfer is way better than I expected. You can see the white plates on top and bottom. You look in between, you're seeing the white as well. And that's just totally optimum because right now the mica is transferring the heat so well. It has the same white on the infrared. And so this has been really my best heat distribution so far. And that's key because if you don't have the right heat distribution, then you're going to have an uneven charge. Now, this is what it looks like when I pulled it out. On the outside, you can see was my PVC. Now, all I do is just cut a PVC pipe into rings, and then I put inside whatever materials, polypropylene, a little Teflon, and that's really it. And then you get these really powerful electrets. You don't need a hot press. As I showed you earlier, you can just use a grill. But here I'm just trying to up my game. If you're wondering about how this electret did, it worked out terribly. I tried a top secret ingredient in here and it actually did nothing. So one of my worst electrets yet, but it shows you the process I use and hopefully you guys can benefit from it. Oh boy, what am I doing here? That was weird. Sorry about that. It just skipped through a bunch of slides. Okay. This is my old setup and I use weights to put on the copper plates. This is just how the plastic flows when it's under heat. Plastic has all these different unique properties when you're cooking them up. And again, I'm using polypropylene and Teflon. Those are the ingredients. It's nothing fancier than that. If you're wondering how much Teflon to polypropylene, the mix is around 10% Teflon and 90% polypropylene. You'll usually get polypropylene in pellets. Good luck on finding it in a powder form. If you ever found polypropylene in a powder form, please let me know or Old Man Builds know because that would be incredible. Now, what you're seeing here is the different shapes that are used for baking candies. And so these are the ones that I've been experimenting with. Adding a lid was a big help. Unfortunately, there's so much metal in here that I can't dial up the frequency, I'm sorry, the electricity higher than 10,000 volt. So that was a bummer. And so what I'm working on is to get ever higher voltages. If you look at the cord here that I'm kind of emphasizing, I cut off the two power prongs and only the ground prong sticks out. This allows me to hook it up and then I can ground out whatever I want and it's grounded out the house ground. That's the purpose of why I'm showing you this. You can see here again, unfortunately, it's only 10,000 volts roughly. Not the 50, 60, 100,000 that I need. Now, of course, the electrics that you've been seeing have been have been under this lower voltage. So this lower voltage works. I have a hygrometer. Um, it tells me the humidity. Humidity is everything, to be honest. If your humidity is 50% or higher, your electrics will just fail. So you need to get that humidity down to under 50%. When you get it under 50%, then your electrics will have a chance. And so what happens is, if it's under 50%, take the electret out and wrap it up in tin foil right away, and then put your markings on it and let it cool down a little bit. Let it just chill for a bit. And then when you open it up and try to take a voltage reading off of it, you'll find that it'll have a high voltage, and you'll find that it can move those aluminum rotors. You can see my process isn't super clean. Um, when you buy the polypropylene for filling like toys, kids' toys, stuffed animals, the polypropylene pellets you can see here are still sort of rough and not melted all the way. And the white powder you're seeing is the Teflon. And so I think Jarvis, sorry, Brent Jarvis likes to call these Rice Krispies. If you just shake the polypropylene pellets in a bag with a little Teflon powder, this is what they look like. And those later or earlier, the cigarettes were made the same way. This is another one kind of showing the setup. I emphasize a lot of the setups. Um, I made a lot of electrics that don't work. Most of these didn't work, but you learn. That's why I'm kind of doing the heads down, feet on the deck plates kind of work, so you guys can learn from my mistakes. Polypropylene and Teflon, that's your winning strategy. That's always your winning strategy. So tragedy, strategy. Again, I emphasize out of the mold into the foil. It's very important. You started a chain reaction when you melted it, when you ran an electric field through it, but that chain reaction will stall if you don't get it wrapped in aluminum foil right away. The aluminum foil pushes it past the tipping point. And once it passes tipping point, then it begins the deep process of charging all of the molecules inside the insulator or the plastic. Some of you guys are going, I've seen these slides before. I know, guys. I'm replaying some of these slides so that way you guys can listen to this at night and it'll put you to sleep. So here we see, again, some of, how many videos can I show you the same thing here? Let me see. Um, so this was an improvement. It's all smooth. There's a little carbon in there, and in fact, some of that little carbon in here has kind of been helpful. So I burnt this one a little bit, and it seemed to help it a little bit. Polypropylene and Teflon. Polypropylene and Teflon. You can see the beads here, the pellets. So I just turn up the grill 350 degrees, and there you go. Run electric field on each side of it, and this is kind of another view. This was a barbecue grill I picked up. I think it's called the smokeless grill, actually. And I used this one for making electrics. Not bad. This is the mess. There's always a mess. Electric making is messy. But look at this. Got some really nice clean ziggurats on that one. And I'm going to throw those right into foil. Again, pull them out. And guys, so this is about as hard as it gets. You just put polypropylene in, Teflon, and put a positive negative plate, add heat. Now you can do this in an oven. You'll just have to try to figure out how to get the electric field in the oven. In fact, it would actually work better in an oven because the temperature is more evenly distributed. So you'll see here I have this little toaster oven. The problem is these toaster ovens are all metal, okay? So when you try to get a high voltage going in here, it actually, originally I thought it was going to be good, but unfortunately, and I'll show you here, this is not easy to do. I get a high voltage going on in this toaster oven, and it was isolated, but it wasn't isolated. What happened was the top field here, which is the positive, so you can see it spraying this copper plate. The positive was isolated. The grounding plate was not. And what happened was, is the whole oven became the ground. And so instead of having those straight lines of the electric field going from top to bottom is what you need, it was getting all of these sort of mishmash of fields. And so getting the plasma in this toaster oven was sort of a fail. I want to revisit this, but I have another idea. There it is. I'm thinking I'm making these great electrets when really they don't work at all, which is a bummer. I get the heat right, but I can't get the field right. On the other ones, I can get the field right, but I can't get the heat right. So that's been a challenge and a struggle for me. There's the setup. I earlier I had the Variac there, the big red thing, powering the precipitator, but actually I didn't need to do that because the precipitator has a knob on it, and the knob allows you to adjust the electricity, high voltage. So you don't need it at all. So I took it out in later experiments. Instead of making some Pop Tarts, I'm making some Electrets here in my toaster oven. And you guys get the idea. I only have 152 slides, so we'll get this done here in the next 90 minutes, I promise. So I was so excited. This was so hard to do, and then it didn't work. Here's an example. Teflon was in the right, polypropylene's on the left. Google polypropylene pellets. You get it on Amazon for 10 bucks. And the Teflon, you're just gonna have to buy it from company. I think it was probably 60 bucks for the Teflon, and all the Teflon you're gonna need for a lot because you only need a little bit. But doing this causes the Teflon to coat every single pellet perfectly, and that's what you want. So you can see here now, the Teflon is actually completely coating them. Now, when you just go from cup to cup, the Teflon gets so charged that these will act like Mexican jumping beans. They'll just fly out all over the place. So you're gonna have to be careful because you'll lose them. This is how I made the ziggurats. This is version 2. I overfill them, and the reason for that is because there's a lot of air pockets. And so I'll just put copper plates on top. This is something I do to everything. Vaseline is your friend. Rub your silicone molds with Vaseline, rub your copper plates with Vaseline, everything with Vaseline. Because one, it protects everything. Two, it is a release agent. Nothing sticks together too bad. All right, so let me see. I think this is a generation 2. So this meter measures 22,000 volts. So thing is over to 22,000 volts, fresh out of the oven. These are some more Rice Krispie. I can't get it out of my head now. Jarvis, Jar Jar. My wife calls him Jar Jar. This is one of my harebrained ideas. I bought a corn mill. And I thought, oh, you know what? I can't find polypropylene powder, so I'm gonna grind it, and it didn't work. It was a fail. The good news is I have a homestead up in Wisconsin. We have a little cottage. I want to grow corn, and wheat, so that grinder will come in handy. Here, you guys, if you guys remember this, when I presented this about a month ago, this is palm wax, and I'm putting it under plasma, see if I can charge it. This is Teflon powder. Oh, and this is another must. You rub Teflon powder into your plates. So Vaseline and Teflon, those are your best friends. Nothing's gonna stick, nothing's gonna be permanent because when you melt plastics, everything's permanent and it's torture. When you want to clean things, isopropyl alcohol is important. Here's my little garage shop, just kind of walking you through what I have here, my little setup. I am working on that Marks generator. That's going to give me 1.5 million volts. So that's coming along. So here's my little mess. Now that my kids are grown, I get a whole day of the garage. So this is my shop that I smile every morning when I get to go in it. That room over there that's all messy, that's our airplane hangar. Let's see if we're doing anything different here. So I'm kind of again just showing you, fill this up with your Rice Krispies, put a plate on top. Oh, I tried, here I tried to just charge little discs. I heated them up, tried to charge them, didn't work. Those are Teflon discs, so the heat wasn't enough. So I bought a kiln. So I'm going to try it again with a kiln because I know my low temp kiln will melt um, Teflon. Here I'm showing you off how powerful the precipitator high voltage power supply is. Here I ran some Teflon powder through my laminating machine. I don't know if you guys ever pick up a laminating machine. I think these are the greatest things ever invented. I love laminating things. Here I'm laminating some charged Teflon and hoping to see if I can make an electret. You can see there's a little pocket of glass beads. So here now I'm mixing glass beads with Teflon. Teflon is extremely negative on one side, and the glass beads are extremely positive on the other side. So if you shake them together, you should get a big voltage. Those are also some more glass beads. I'll show you how that lamination works later. I think my slides are out of order. What I'm showing off here is that if your humidity is high, like Brent Jarvis lives in Georgia and the humidity is really high there. If you heat up a smokeless grill like this, and what it does is it creates a whole low humidity environment around it, and that allows you to work on the electrodes. So yeah, it's a bummer because you're working over a hot stove, but if you want the humidity to create electrodes, you're definitely gonna want to have some kind of pancake grill. This is a smokeless grill, something cheap you can get at the thrift store. Heat it up, and then it'll alter your humidity, dry everything out, and as you're working, you'll get good electrodes. You can follow every step perfectly to create an electret, and your humidity is higher than 50%, and you're almost most likely going to fail. And you're going to go, oh my goodness, Shawn, I tried your recipe and it didn't work. You have to get these hygrometers are for $10 on Amazon. You might want to screenshot this. Get your humidity down, otherwise you'll be tortured trying to create your electrodes. Here I mixed epoxy with Teflon. I was thinking that I'll run electricity through it until the epoxy hardens, and this was an epic fail. I'm going to try to revisit this later, but as you can see, I'm just about trying every kind of method to make electrodes. Is this where I shake it? There's kind of a repeat here. So I'm preheating the electrodes as well, kind of baking them because the humidity is higher. So putting those in tinfoil on the grill with a 29% humidity, it's going to dry those electrodes and allow you to do things with them. You don't want high humidity in electrodes, they're enemies. This is the fancy grill I picked up. These are my 3 beautiful meters. The one on the left is an electrostatic meter. It's an FR00. 3 or FXR003. This is a 4, sorry. I don't recommend buying the 4 because it's $150 more, and it only measures 2,000 more volts. So if you get the 3, you'll pay about $160 in Amazon, and it'll read 20,000 volts or lower. If you pay another $150 or more for this 4, then you can only read 2,000 volts more. So I've made the mistake. I would buy the 3. This middle meter is I think is mandatory. The red lights here can turn red or blue, telling you the distance and the field density of the electric fields that surround your electret. Now, this is just a regular meter on the right. So you can actually plug your meter right into this E-field meter, and now you can quantify the field strengths of your electrets. Here's one of my electrets, not fancy. Looks like a mess, but look at that. That's an aluminum vein, and look at how fast the charged field in this burnt piece of plastic looking thing can draw that. So it can do work right away. So polypropylene, Teflon powder between 2 plates works every time. You can see that this is working in the thousands of volts, 16,000, 10,000. Now, these aren't true voltages to be accurate because you really need to hold the electret a perfect inch above the meter. That gives you its exact voltage. And its exact voltage, if it's showing 18,000 volts here, its exact voltage is probably only about 2,000 volts. Now you're probably asking, well, why don't I then just keep everything 1 inch away and take that reading? Well, because it's way more effort. This is just easy. So just slap it on your meter, write it down, and then go to the next one. So I mean, it still reads high voltage. It still tells you possibility. So this field here, you can see this electret here is blue, so it's showing it's negative. You can see for each bar tells you its intensity. Now you'll notice at first you'll say, well, that electret's weak because it only had 2 bars. But if you'll notice here with my arrow, there's a high setting and a low setting for sensitivity. I put it on low, so each bar is really equal to 10 bars on the high setting. So this electret is super powerful because 2 bars on the low setting is incredible. And so I'm showing you how this is the high setting. So you can see how it fills up the bars quite easily. I put these spacers here. They ended up being a mess, so I just took them off. Here I'm showing you how far my electric fields will show up on the meter. And so I'm about, I don't know, 18 inches away, 2 feet away, and it can see this electret. So we're looking at a 4-foot diameter field probably on this one. It's also negative, as you can see. It's in blue. And that's interesting because it showed positive when I made it, but a couple weeks later, it switched polarities from positive to negative. There's a bizarre reason for that, which I'll explain probably later here. But yeah, very strange. All of my electrets start one polarity. Couple weeks, they switch to another polarity. And the polarity that they switch to is the permanent polarity. Just to add a little bit more confusion there when you're creating these things. So I'm just kind of showing you how powerful and how far reaching these fields are. This one I'm showing you how it's on the bottom. It also shows you that there's strong positive and strong negative polarities. This electret I thought was going to work incredibly. It's actually shaped into little almost quasi my goodness, Mandelbrot sets. I can't think of the word, and it died the next day. So it's another thing about electrets. They'll wine and dine you, and then the next day they break up. So these were some really failed electret experiments. You'll notice in my right hand here, I'm holding this alligator clip. If you want to get super accurate high voltage measurements, you need to ground yourself and you need to make your readings on a metal surface. It doesn't seem, it almost seems counterintuitive. You would think if I want to make high voltage readings, I want to be on an insulator and, just a rubber mat. No, it's the opposite. You got to have metal for all of your stuff. Measurements in metal, store them, electrics in metal. Metal, it has a big role in making electrets. Just testing different electrets. These are my spheres that I attempted. This is pure polypropylene. When I first started, I just did pure polypropylene or pure polyethylene or just all the cheap plastics you can buy. You can get PE, PP, you can get urethane pellets. These are all different plastic pellets used for making dolls or filling pillows, bean bags, that kind of stuff. And these are pretty cheap. And so you can see here, uh, excuse me, running up something with my nose. Um, the sphere worked for a little bit and then it stalled. The reason why it stalled was because you need to mix it with something. Excuse me. It's one of the Rice Krispies and it's working. This is actually I mixed wax in this one with the polypropylene and the Teflon powder. It's super ugly and super weak, but it actually worked. It was actually a working strategy. I didn't stay with the strategy with the wax here because the wax doesn't like to mix with other things very, very well. Otherwise, I would have used it more. You can get smaller high voltage. This one only costs $15 on AliExpress, and it's plenty. It's 10,000 volts. It's respectable voltage. The reason why I keep emphasizing these is they're super cheap and they're very strong. And you need strong fields, electrostatic fields when you're working with electric. I'm doing some distance measurements for the intensity again. So there's nothing fancy to these little rotary electroscopes is what they're called. A rotary electroscope. This top piece is aluminum. It's aluminum all the way through. Um, the rod is actually solid aluminum. This is kind of how they work. This is one of my better electrets when I first started. It's pretty powerful. Being a first generation, um, I was surprised that it can do this. So again, I'm performing work. I'm performing mechanical work from a little piece of plastic that has an immense charge in it, and that charge is permanent. Look at, I'm going to put the brakes on here. So it has the attractive and repulsion. So this is a respectable field, and it's permanent. Now, what happens is if you use it for a while, say 5 minutes, about 1 to 5 minutes, the charge goes down significantly until you can't do anything more with it. So what you do is you put an aluminum foil, come back in a couple hours, pull it out, and it's completely charged again. Some charge within as little as an hour, others charge within overnight. Depends how good the electrets are. This is an electret that I used wax with, and it's a ziggurat with wax. Um, it worked okay. The field diminished so greatly. I feel like wax is just, it's not good for initiating the polarization. I think wax is better at freezing the polarization that exists. So didn't have a lot of luck with the wax. And this is a very specific wax. This is Cornoba wax. Just look up palm wax from the palm tree. and you'll get it. I think it's palm tree resin is exactly what it is. You can see I'm using the field strength meter. These meters aren't super expensive, but they're not cheap. So, but this is if you want to work with and see where your electric fields are and their intensity, you really need this meter. This meter gives you a visual display of where all your fields are and what are their polarities. And you can Google e-field meter on Amazon. That's where they sell them. That's where I bought it. I think they're made in the United Kingdom. More tests. Um, you'll notice that parts of the bottom of here, the ziggurat, are negative and other parts are positive. And that's because of the uneven distribution of the Teflon powder inside the polypropylene. I think I'm going to electret you guys to death here. So I'll be closing here in a little bit. Unless I look in the chat and you guys want me to go longer. I'm just kidding. Hey, we've got a good group of guys and gals. Gal? Let's see here. So these are workers. I have shaky hands, so I always tap it on accident. But you don't have to move these rotors by touching it. Here's one of my failed polypropylene uh, molds, sphere molds. This is pure polypropylene, pure PP. Now these fields were gone the next day, so these were just more surface charges. That's another thing that will pull your hair out regarding electrets, is to tell the difference between a surface charge and a spatial charge or a volume charge. I really want the volume charge. I want the charge to be all through the entire electret. So that's the desired. That's what's desired. You can. So I think this is urethane. They had urethane pellets. Do not use urethane. It smokes. It burns easily. It shows this beautiful promise here. Next day it's gone. So they're just like kind of one day fun and then no more. Another sphere. More spheres. See if we can get a different mold here. This is another one of my winning recipes. Teflon and polypropylene on a thin disc. I used a PVC ring as the mold. You're probably saying I keep saying the same thing. Yep, I am, because I want to be repetitive so you guys can do this. I'd really love to see you guys get Teflon and polypropylene. Get an old get one of these inexpensive power supplies. Put it on a thrift store grill, and you're set. That's it. That's all you need. So again, you're seeing that the possibility of these doing work. Look at this. It's pretty incredible. Running on plastic power. Here I do some distance tests. My best distance right now is a 3-foot radius or a 6-foot diameter field. And when you think about that, a 6-foot diameter field, that's incredible considering how small these are. And these are these are only my generation 1, some of them generation 2. Generation 3 is gonna, if I'm correct, they're gonna be about 100 times stronger. So I think that Gen 3 is gonna be the ones that power motors. We want to get there. We want to get these things powering a motor. I took a light bulb and some copper tape, and I made this high voltage motor. It's hooked up to the high voltage power supply because I was testing it. Wasn't really good for electrets. Brent Jarvis sent me a really good design, but this is the goal. I want to put an electret on each side. I want to run a motor. I feel like I'm close, but not quite. I'm kind of showing you that in these little plastic petri dishes, if I just sort of shake them with certain plastics, they build voltages. So I'm just kind of measuring and learning how high voltage works. This was the light bulb that I used to make that motor. I used one of those rotors, and that was it. That's all you need to make these high voltage motors. There you go. This is a burnt mess, but this is actually ended up being one of my best Electrets. This is a Gen 1, Generation 1 Electret, um, but it ended up being super cool. Um, I think this was fresh off the grill, so I needed to put it in tin foil. But I'll tell you what, sitting for weeks in the tin foil, this thing's pretty powerful now. Tin foil, you can kind of see now there's a kind of a rhythm or a, kind of a just basic set of polypropylene and nylon. This had the copper plate touching when it was being made, and this really supercharged it. So I try to get the charge plates as close, if touching the electret plastic as I can. So that's important. Here's a little motor that I tried to make. Um, it was a flop, but it looks cool. Oh, so that laminated paper I showed you, here is the control. This is a piece of laminated paper that went through my lamination machine, and you'll see that it's not doing anything. You can see, well, checking each side. It's the air. Now, did you see me shake it? Nothing happens. Now I'm going to shake the laminated Teflon and glass beads. I just ran them through the lamination machine to shake them, and check it out. I got a high voltage. And this one's pretty crazy. The more you shake it, the stronger the electric field. I haven't played with this more, but I thought, look at this. Look how strong it is. I keep hitting it because I'm clumsy. If I didn't hit it, this thing would be spinning fast. So yeah, this is shaken shake powder, shake energy. That's all it is. Glass is positive, Teflon is negative. So, and the distance between them is great. And because the distance is between them is great, when they rub by each other, they create high voltages, very high voltages. This is another, this is generation one. I'm trying all kinds of plastics. I'm trying all kinds of methods. You guys get the benefit of polypropylene and Teflon, but it was trial and error for me. The Teflon and polypropylene is so strong that even the mess ups, the overfill flakes, is that's 22,000 volts right there. So it's just a great um, mix. And I put these little flakes in tinfoil, and I can pull them out a week, 2, 3 weeks later. They still hold thousands and thousands of volts. So it's pretty interesting. I hope you guys are learning some ideas, getting some ideas for home. Oh, I'm shaking the. I think this was my second. So air on a laminated paper gives you a little bit of charge. Um, I think this is a different lamination setup. Yeah, I think I added more glass to this one. The shake it power. Yeah, come on, you can do it. You can tell your friends. I just sat through an hour of a guy playing with plastic, shaking plastic, electrocuting plastic. Yeah. Oh wow. So if you, so here's another thing I learned. If you fold it and just apply a little bit of pressure after you shake it, look at how powerful this thing is. And it's that crease right there. That crease right there is a super powerful field. It's something that I want to take into my future um, electrics is to create these creases because it works with this goofy laminated electric. You saw it yourself. Incredible. Nothing fancy. Lamination paper between with a Teflon powder in between. Then run glass beads with paper sheet, sorry, lamination sheet on each side. Run it through, and then run them both together on the 5 mm setting. Boom, that's what you get. You get a shaking, super high voltage power supply. This is a different powder. I'm experimenting with different powder polymers, and this one showed promise. This one is, I want to say it's PVC powder. Pretty cool stuff. And more I'm trying to show. Oh, that was my burnt one. Look at how strong it got. This is a couple weeks later. So so there's a couple phenomenon going on. One, if you pull it off the grill and take it out of the electric field, look, it's all burnt and irregular and ugly. If you take it off right away, put it in tin foil, and then later pull it out to do work, you will get these powerful electrets. It's pretty incredible. So I'm showing off because this thing's just totally crazy. Another thing about polypropylene is you'll see that its voltage drops really slow. Other materials, I did the same test, and they'll go from their top voltage down to their bottom voltage in like 30 seconds. But polypropylene, it holds its charge for minutes. I want to say you can get about 10 minutes of charge from polypropylene. So that's why it's such an incredibly good material for electrets. And so, and you'll notice other electrets will peter out real quick. Not polypropylene. It stays. It holds it. My theory on the polypropylene holding it is that polypropylene is hydrophobic. Now I'm using that big word and acting like I understand it, but I actually learned it from Brent Jarvis. All it means is that it doesn't allow any humidity to settle on it. And that means that it's going to keep its charge. So more and more. Oh, wow. So here we go. We started with a ziggurat and we're ending with a ziggurat. And that concludes my presentation, guys. Thanks for hanging in there. It's been a full hour.